You're listening to Conferences Online Allergy from Children's Mercy Hospital in Kansas City, Missouri. Today is August 12, 2024. Our topic is Aerobiology, air sampling for pollen and spores. This is presented by Dr. Charles Barnes. He is a professor emeritus at Children's Mercy Hospital in Kansas City, Missouri.
Dr. Barnes in the next hour is going to talk about aerobiology. This is a terribly important topic. It will be board material coming down the line, so it's a good reference to get back to. With that, Charlie, thanks again for being here, and I'll hand over the controls to you.
Okay, thank you very much, Chris.
Thanks.
We're going to spend the next hour or so talking about what's in the air. And the picture of the plant on your screen, I just took a couple of days ago, and that's a giant ragweed that the county mowed down about a month ago, and it's already grown back to this this stage. And about now, it's starting to get little flower projections on each one of these tips. And in a few days beyond that, it's going to start dumping pollen into the air. And so you really, and then this pollen, of course, causes a lot of allergy. Much of it nowadays has gone over the counter, and with the large over the counter and the very good over the counter drugs, you probably don't see as much of this coming into your office, but I bet you still do see a lot of kids coming in with that runny nose and the allergic salute and the allergic nurse. And so this is around here, the part of the year that you get probably more of that than just about any other part of the year. We're going to try to learn some of the common air collecting devices. If you go out to another practice, and probably at least 100 other practices in the country, and maybe more than that, do a pollen count collection for their local area and report it on the local news and use it for public relations. And a lot of times the incoming fellow is the one who's put in charge of that. And so you need to know a little about it. Plus, these questions tend to pop up on examinations. You can take a course when you go to the academy meeting, and sometimes when you go to the college meeting, on aerobiology and how to identify. If you're really interested in this stuff, you can learn a lot more about it. It goes pretty deep. You'll find that quite a few allergists are also amateur botanists, and they like to grow things, and they like to know what's growing in the local area. And they generally are the people who get questions about strange things in the air. We're also going to learn a little about what's local here in Kansas City. We get just about everything but olive around here, and instead of olive, we get ash. But we get lots of different kinds of pollens and lots of different kinds of allergens in the air. And then a little bit about how air, the reported, it's called an air count or pollen count, but actually it is a statistical estimation of the approximate number of pollen grains and approximate number of airborne spores. And so these things are really just statistical estimations, although the local radio station or TV station will count it, will treat it just like it's solid information. So we're going to understand how air samples are taken. We're going to understand how they're taken for indoor spore counts if we get that far. Because indoor spore counts, every now and then you'll have a patient come in with a printout of a indoor spore collection, and of course they expect you to know all about it and how to interpret this. And then we're going to go over major indoor and outdoor aeroallergens in the Kansas City area. And all of this falls under the field of aerobiology. Aerobiology is a really large field. It sort of hides in plain sight a lot of times, but you see aerobiology used all the time. NASA actually has an aerobiology laboratory, and they have a really good definition of what aerobiology is. The atmosphere is home to a wide and diverse array of microorganisms, bacteria, viruses, fungi, even things like flying grasshoppers that are migrating from Mexico up to the United States and then back again. These life forms hold clues to big questions such as where and how life evolved and if it exists elsewhere in the universe. That's the NASA perspective. Aerobiologists, they say, study the organisms and particles of biological origin known together as bioaerosols that float around in our planet's atmosphere. Aerobiology research is rewriting the book on Earth's atmosphere. It's also helping understand where life might exist elsewhere in the solar system, such as on Mars. As far as I have watched, and I watch it pretty closely, they really don't have any solid evidence of life on Mars yet, but they sure are looking for it. Why is this applicable to you? Well, this was a collection in 1995 that we did of emergency room visits for, and then a lot of it back then was for asthma or allergy, and spore count in the air. And you'll notice that right about September, the spore counts increased and peaked, and the ER visits increased and peaked. Now, there are lots of other factors here, and this is just an example, but unless things have changed, for the second year fellows, you'll be looking for this September peak in people coming in with allergy problems. And if you're a first year fellow, this will be the first time you'll see it, but keep an eye out for it. It kind of peaks as ragweed peaks in about the second week in September, and then as we start to get toward fall, is all we get. We got lots of falling leaves. We got lots of dead and dying vegetation. We get lots of fungi that are growing on leaves and plants start to throw their spores out in the air. And so this September peak, although you have done a lot of things, Jay put in some programs to try to blunt this September peak, and the medicines that you can get over the counter, people take a lot of them, and might have blunted this peak a little bit, but I bet if you really checked on it, it would still be there. These are the kinds of things that you use to collect. Over here on the left is a Allergenco air sampler. We use these mostly on the indoors, but we also for several years used them to collect outdoor data, and they did a very good job. This is a rotor-rod. We also used it for a few years to collect outdoor data. It's really good for pollen, not so good for spores. This is a Lanzoni. This is a Burkhardt device. They're both Hurst spore traps. And this is, I think, what you're using currently to produce pollen counts. It's a pollen sense. It's basically all automatic. I think all you have to do is reload the supplies in it periodically, and it produces a picture of the air collection. It sends that off for artificial intelligence analysis, and it can pick out spores and pollen, and I think it does a pretty good job, but there's a little controversy about it. So this is a spore trap. Basically, you need some device where you can pull a vacuum, and so the vacuum draws, if you have a vacuum in the interior here, the vacuum draws air from the outside through a slit right here, and so in front of the slit you have a glass slide or a piece of plastic or something that's coated with a grease. Vaseline grease will do. Silicone grease does a good job. And as air comes rushing through here, the air goes around it. Anything heavier than the air will go flying into the slide and stick. And so you produce a little collection of, say, a day's results here. And this was produced back in 1972. And so, this kind of technology is not all that new, but not all that old. This is a Burkhart that we used to use at Children's Mercy, courtesy of James Anderson, who did collections in Ontario, Canada for years and years and years. And there's a pump down here that draws a vacuum into this chamber. There's a slit in the front here that pulls air through there. The air goes smashing into a slide right here. And so you get a collection from early in the morning to early the next morning, a 24-hour collection of what's in the air. And you can look, this would be James is changing his slides about 6 o'clock. So this was a morning rush hour. This is kind of noon. This is a afternoon rush hour. This is overnight. After the dew falls, the particles kind of go down, and then you're back at 6 o'clock in the morning with a morning rush hour. So it's a very interesting collection to make. It's a really hands-on unit here. You just take this collecting head with the one coated slide on it and take it out of the unit, change the slide every day, put it back in the unit, and then you take the slide back to your laboratory and put a stain on it, put a cover slip on it, and look at it under the microscope and count 1, 2, 3, 4, 5 the number of pollen grains you find in a particular area. And there's several ways to count. A lot of times people will just do one trace horizontally all the way across the slide and take that and calculate a daily count out of it. But basically you take to do this count, you take the number of pollen you count, you divide it by the amount of air, the volume of air you've collected for the 24 hours, and that gives the number of pollen average per hour for 24 hours. And that's a pretty good indication of what's in the air, but it is just an indication. Okay, and this operates off a clock system. It's wind up. So one of our major problems that we had with this unit was the clocks, because people these days are just not used to wind clocks. And so we had, we get clocks overwound, we get clocks underwound, but overall it's a pretty reliable system. Now there are lots of other air collecting systems, and this is one of the most interesting that I've ever seen. This was when the plant pathology department at North Carolina State was collecting tobacco fungus that blows up from Cuba and affects the tobacco crop. And so he was looking for tobacco fungal spores at different heights. And so he's got 4 different petri dishes on here on his little airplane, and each petri dish has got a little window in front of it that turns sideways at a certain point and then closes. And so he would fly it to a certain point, open up one of these windows, get so many spores smashing into the petri dish, close the windows, move to a different height, get more spores, and so on. So this is a really interesting collecting device. These grants don't really exist anymore because you don't get a whole lot of tobacco grants these days. There's also a rotorod device, and I put this in here just because I have gotten questions over, can we still get parts for rotorod devices? And I checked a month ago or so, and you could still get parts for rotorod devices, and you could still get materials and things like that from either Pollen.com, which was in Plymouth Meeting, Pennsylvania, or the Aerobiology Research Laboratories in Ottawa, Ontario. And this data, this is from Pollen.com, is on the internet. You can get it for free. Pollen.com. When I was active in the American Academy for Allergy, Asthma, and Immunology Aerobiology Bureau, had wrapped up there's pretty much all the drug company advertising, and so you would see, you would see the pollen count in Des Moines, sponsored by Pfizer or sponsored by Genentech or something like that. The National Allergy Bureau also puts out a pollen count. Now, the pollen.com count is a projection. Yeah, they are projecting the pollen count into tomorrow, into what it's going to be today, and what it's going to be tomorrow, and what it's going to be a couple of days from now. The National Allergy Bureau, which is part of the American Academy for Allergy, Asthma, and Immunology, puts out pollen counts for today. Now, they don't, and this is just an aside, they don't really recognize the automatic spore counter. And so if you look on their site now, there will not be values for Kansas City for Children's Mercy. But until a couple of years ago, we put out a daily pollen count that was done manually according to their methods, and we were a regular part of the National Allergy Bureau. And that's a committee at the American Academy for Allergy, Asthma, and Immunology meeting. If you go to the meeting, go to some committee meetings. It's pretty easy to join a committee, and you definitely get to meet a lot of people that have interests similar to you. Okay, so this is just what a rotarod device looks like. It's basically a spinning bar with two lucite rods attached to it. The rods, again, are coated in grease, and they are put in once they're full of pollen, they're put in a stage and stained and counted manually. And it just normally these things are. This one is upside down because it's only going to sample for a short period of time, but it's easy to see. So it just spins, and you have to do a calculation involving pi to calculate the amount of air these things sweep through, and from there it's a relatively simple calculation to produce a number of pollen per cubic meter of air. There have been comparisons made between the various collectors, the Burkhardt device and the rotarod device. Burkhardt was better for smaller particles. Basically, both instruments appear to record the same relative changes in airborne pollen concentrations. The Burkhardt appears to be a superior instrument for sampling particles less than 10 microns. That's going to be spores. Almost all pollen are greater than 10 microns. The rotarod appears to be equal or superior to the Burkhardt for collecting particles greater than 10 microns. So the rotarod is good for pollens and big spores. The Burkhardt is good for pollen and small spores, but the efficiency of any collector drops off pretty fast once you get into the 1 or 2 micron range for spores. So, there's still some things out there that are really not getting counted well. Now, compared the Burkhardt and the Allergy, did this work a couple of years ago, and they were basically the same. We thought the Allergenco was a little better when counts were low, and when air velocity was lower, and the Burkhardt may have been a little better when counts were high, but they basically were compatible. And so, you don't really have to spend a whole lot of money to get good pollen counts. The Allergenco did get some trouble, though, in rain, and no pollen collector I know of is good in snow, because you pull a snowflake in through that device, and it just washes the stuff away. But also, when it snows, pollen and spores in the air stick to the snowflakes, and they all just precipitate out. And so the air is never cleaner than right after a good snow. Now, all of these older units, classical units, rely on a stain to stain the pollen grains and some kind of osmotic control, generally glycerol, to cause the pollen grains to swell so they all look a particular way, not depending upon the moisture in the air. This is a cuprese or juniper pollen, and this one is always very characteristic. This is the Pac-Man pollen. Basically, what's happened is the interior of this pollen, under the effect of the glycerol, has swelled and burst through the outside, and what you see is basically the husk of the outside, and most of the time it looks a little like a Pac-Man. And so this is the infamous Pac-Man pollen. Now, the pollen sense doesn't use a stain and doesn't use an osmotic control. So what you get is a picture of the junk in the air, the whole picture, without any real differentiation. Like this is a flake off an insect or a plant. Probably this is a plant. Flake, micro particles floating around the air. And somewhere in here, there are probably a couple of pollen, but I really can't tell. However, using artificial intelligence to identify the pollen, they've done a pretty good job of producing a pollen count. And it produces a moment-by-moment pollen count so that you get much more granular information. It goes on the internet almost immediately. However, I don't think you have access to it. That's where they're trying to make their money, selling immediate access to pollen counts. Okay, so what pollens do we have in Kansas City? Well, we have lots and lots of pollens in Kansas City, but this is kind of the top 10. And sort of by the time of year that it presents itself, although the cedar, elm, and maple can swap around a lot. Generally, we can see a little elm or sometimes maple in January or February, but most of the time, this doesn't really pop up until the end of February, 1st of March. Elm trees, maple trees, the cedar trees depend absolutely on the weather. If we have a warm spring and the weather hits just right, cedar trees will pollinate in January, middle of January. They'll even pollinate in December. Oak trees generally don't come on until about April, along with mulberry. And mulberry is a big group around here because it contains all these osage trees, the Maclura osage trees that we see so frequently in this area. Then we have our first weed, or weed is sorrel. Then generally around June, we start to get grass. In May, June, we start to get different kinds of grass. Most of them are northern pasture grasses. Then we start to get another weed, plantain, that can last till August or so. Then we get ragweed, and it starts in the middle of August, ending about the middle of October. Makes people really miserable. And chenopod kind of goes along with ragweed. But the ragweed, for most people anyway, tends to be a little more allergic. So this is what an elm pollen looks like. This is what an elm tree looks like. These big trees that branch out, that have nice spiny type leaves on them. The elm pollen is stephanoporate, which means it's got pores all the way around the side, but not in the middle here when you look at them under a microscope. 4 to 7 pores, generally 5, and a curvy intine. That's the character of the interior here that you see. The cedar, again, these things pop under the stain, and you see this Pac-Man-like configuration for cedar, and it can be blue, or depending on what stain, it could be black, or it could be fuchsia. So, and this is a really big cedar tree out in my pasture here, and if you had picked the right time of year and you throw a rock at this cedar tree, you just get this cloud of dust formed. And so cedar pollen doesn't last in high levels for a long time, but when it pops, it really pops. Levels can just shoot up. And they are in the Cupreaceae family, including juniper and western red cedar and white cedar and eastern red cedar and things like that. They're inapterate. They don't have any holes in this thing. The exine is thin. That's this part that popped off. And the intine, the interior right here, is thick. And so this stays intact and this breaks. Oak trees coming on about April. We've got 50 different varieties of oak trees in the Missouri area here. We have pin oaks. This is a post oak. They produce catkins, and each of these are little flowers. There's just a string of little flowers here, and each of these flowers is just dumping pollen into the air like crazy. And so we can have some really high oak pollen levels. If you live over in Johnson County along the Lamar corridor, where they planted some beautiful oak trees many years ago, and you leave your car outside, you're going to have a yellow film all over your car. There's so much oak pollen in the air. Which brings us to a point. Generally, trees and plants with big, pretty flowers or nice, fragrant flowers don't produce pollen. They are pollen that are small enough to go flying around the air. They generally produce big pollen. They're pollinated by insects, and they are known as entomophilous. But plants that have little bitty flowers that most of the time you don't even see, and thousands of them are pollinated by air, or they're anemophilous. And they just basically throw as much pollen into the air as they can, hoping that it's going to land at the right place. And these are the pollens, these are the types of plants that typically you see as a problem. And mulberry, we start to see mulberry coming along. And mulberry is a large family, the Moraceae. Typical mulberry pollen is just small and with openings on both ends, apertures on both ends. This is a really large mulberry tree. Typically, a lot of mulberry trees are just brush. You see a field full of brush, about a third of it or so will be a mulberry tree. They produce a pretty nice fruit. I like to eat them. I had a little white horse that loved to eat them every April or so. His muzzle would just be stained absolutely purple. Sorrel is actually a edible weed, and the health food people kind of like sorrel. If you in Britain, I think in a lot of fancy restaurants, you can order a sorrel salad, and I have seen people pick sorrel in the area. It has a kind of a tangy taste to it, but you have to pick it when it's young. You have to know a lot about it, because otherwise it's tough and stringy and bitter. It produces a interesting seed head that turns brown and produces pollen. It looks like it doesn't look like little flowers at all, but it throws a lot of pollen in the air. It's trichoporate, which is a fancy term for saying it's got 3 pores and 3 in each pore. It's got a slit by it. Okay, it goes on to name things like sorrel, curly dock, things like that. It's in the Rumex family. Grass, most of the spring grasses we get around here are related to one another. They are always monoporate. They have basically one hole in the outside. They're generally rounded, and sometimes you can see the granular on the inside because they're in the Gramineae family, and they basically come from plants that produce grains. of starch, and so a lot of times you can see the starch grains on the inside of one of these. And things like timothy and fescue in the spring, and then even though it looks pretty much the same, about this time of year we start to get Johnson grass around here, and we also have a fall pollinating grass called red top that you see in a lot of the fields. And the Johnson grass will also produce this pollen that looks almost exactly the same. Corn produces a pollen that looks almost exactly the same, except it's real big. And so this Johnson grass, you can see grass in the air all year round. The Johnson grass allergy picture, or allergens, tend to be different from the spring pasture grass allergens. And so you see Johnson grass and Bahia grass and things like that for people who come in with a grass allergy in the late summer and fall. Plantain, interesting looking pollen, looks kind of like a ball with small holes in it, generally less than 15 holes. It's that weed that when you mow your grass and the very next day you'll see these spiky things sticking up. It looks kind of like a lance or a spear, and it's called Plantago lanceolata, and it flowers from the bottom, and as it goes along it flowers higher and higher and higher and higher. That means you get these things, this plantain pollen in the air from say July until frost, basically. And this is the English plantain, and this is the American plantain, and they produce a similar type pollen. They just have the plant just has a different look to it. And this, never mind. Okay, missed one. This ragweed, the ragweed pollen just looks like it would irritate your nose. It's sub-echinate. If you played video games, you know what an echidna is, and that's a spiky little rodent type creature. And so these are sub-echinate, lots of ragged looking surface area. It's in the ambrosia family, and they are trichoporate, which means if you look really carefully, you can divide these into three areas, giving a trilobed appearance. It comes in two forms. Well, actually, it comes in several forms around here, but comes in two main forms. This is short ragweed, and they say it's short ragweed, but I've seen it grow 6 feet tall. But generally, this is the ragweed that actually can grow short enough that you can see it underneath where you mow on your lawn if you look closely. And this time of year, again, a little seed head pops up and a little flower head, and it starts to throw out pollen. And this is a giant ragweed, and you can see it growing a lot of times in creek beds and along the sides of roads by rivers and things like that. And it can get to be 8 feet tall. And right now, it generally, we generally pollinates first. And again, you get a seed head popping out of here with lots of little yellow flowers on it, and they just dump tons and tons of pollen. These are in the sunflower family, and so they are sun-related. So on a cloudy, rainy day, it tends to inhibit their pollen a little bit. On a bright, sunny day, they throw pollen out in the air like crazy. This plant, if you taste it, it's so bitter that nothing eats it. As far as I can tell, it doesn't have a single animal or insect that consumes short ragweed. The giant ragweed is not quite as bitter, and I have seen deer and horses consume it, especially the seed heads. But these things are really well adapted to this area. There's a place over in Sedalia called Ashland Farms that produces ragweed pollen commercially. This is a chenopod. So about this time of year, just about any really weed plant you see out there, if it's not a ragweed, it's a chenopod or an amaranth. And there's the botanists have been fighting over these names for a while, and I think amaranth is starting to win over. But I like chenopod because chenopod means goosefoot, and a lot of times when these things are growing out there and they're a little short on water, the leaf kind of droops and looks just like a goose's foot when it's trying to swim. And these are the things that the people come in and say, oh, I got ironweed or I got pigweed. This is lamb's quarters and pigweed, and these names are not exact. And so unless you've got a scientific name on them, you really can't take the patient's word for it because they may or may not be correct. But a good skin test will generally give you the information you need about what kind of weed it might be. Okay, let's look at the top 10 spores in our area. This is a puffball. It was growing out in my front yard last year. These are really interesting. You get this fungus mushroom grows up in a ball, and so it will grow and mature and get dry, and it will get a little small hole here in the top. And when it used to be a picture on the end of it, and when a large raindrop hits this ball here, it puffs spores in the air, and so it's kind of a mechanism for waiting until you get a rain to start dumping your spores out. But this whole thing here is just full of spores. If you bust one up, you get a real dust cloud out of it. But we get for fungi in our area, fungal spores, we get Cladosporum, ascospores, which is just a big catch-all category, Basidiospores, which is another big catch-all category for all mushrooms, so this would be classified as a Basidiospore. We get Alternaria, smuts, which are plant pathogens, Epicoccum, Pithomyces, rusts, which again are plant pathogens, Bipolaris sporum, which are characteristic looking fungal spores, and Aspergillus and Penicillium. We don't get a lot of Aspergillus and Penicillium outside, especially in an air collection on top of a building. And if we do, that generally means there's a real garbage dump or something decaying in the area here. But the names cause quite a quandary. Basically, fungi produce spores in an asexual manner or a sexual manner. The asexual reproduction basically produces a clone of the original spore. And things like Cladosporium, Alternaria, Epicoccum, Pithomyces, Bipolaris, and Aspergillus penicillium are all asexual formations. And they all look the same. So, you can identify those on an air count. However, they also have a sexual stage, and the sexual stages really don't look the same. They look different enough so that they get lumped together in this big group called ascospores. And ascus basically is a Roman word for sac, and basically they are produced 8 in a bag, and the bag breaks generally upon a rainfall, and spores are shot out into the environment. And that's so the pattern is you get a rain, you see high ascospore levels, it starts to dry out, you see high cladosporum levels, you get another rain, you start to see high ascospore levels again. Ascospores can really push the counts up. I mean, they can push the counts up into the 30,000 range or above. And Basidiospores are also like that, but Basidiospores are a lot more subtle. They are produced on a spike or a stool called a basidium. and produced generally on the underside of a toadstool mushroom type situation. So let's look at some of these. This is Cladosporum. You can see how the new spores are being produced right directly off of the old spores in an asexual manner. And basically this spore is pretty much a clone of this spore. And this spore is pretty much a clone of this spore. And Cladosporum is characteristic because you can have up to 3 or maybe even more different spores forming off of a single parent spore, say. A lot of times they're formed in a chain or a line like this. We see a lot of Cladosporum in the air. It's probably the #1 spore in the air that can be identified, but not a whole lot of people are allergic to Cladosporum. So you don't see a lot of Cladosporum allergy. And then we see a lot of ascospores, and so this is an ascospore. This is an ascospore. I hope you can see my pointer. This is an ascospore. This is an ascospore, and they all pretty much look different. But if it's a spore and it's completely surrounded by a membrane, it just gets lumped into the ascospore group unless it's characteristically brown and asymmetric, in which case it becomes a basidiospore. Like this, okay? And a basidiospore will have, whereas an ascospore has no openings in it, a basidiospore will have 2 openings. One is an attachment site, and one is a germ pore that it would allow, since this membrane is pretty thick, would allow genetic material to flow out of it. Basidiospores are mushrooms, basically anything from an agaricus to a ganoderma. Common mushrooms that you see growing out in the fields, sometimes in a circle called a fairy circle. The spores are not toxic. There are people, quite a few people sometimes, allergic to basidiospores. Yeah, they're all pretty much mushroom spores. Alternaria is one of the spores produced in an asexual manner, generally in a chain like this, but normally when you see them, you see an individual alternaria. It has both transverse and horizontal septations, and it has a tail or beak. And some people call it a beak and some people call it a tail, and I don't want to get into that argument. But alternaria is a really characteristic spore when you start to talk about people who get asthma. It's the one type of spore that's been associated with emergency room asthma attacks. You tend to get a lot of this released when you get harvesting activity. You see that combine going down the row in the field, and there's this big cloud of dust behind it. A lot of that will be alternaria. And so it's a bigger spore too, whereas the ascospores are maybe 3 microns or 2 microns. The alternaria here will be almost 20 microns in some of the bigger ones. So it's a really big spore. It carries a lot of allergen with it, and it's the one spore that's really been associated with allergen problems a lot. You get smuts. Smuts are just these little black spores that grow on corn and other plants. And if you grab some corn smut off a corn plant and rub it in your hand, it looks like you rubbed charcoal or something on your fingers. Epicoccum is another large spore that kind of looks like a soccer ball. It's interesting, easy to identify. And so you can see quite a few of them in the right circumstances. Pithomyces, again, is very much like an alternaria, but it has no beak or tail. And rusts, again, are plant pathogens. A lot of times you see wheat rust around here. And so during the wheat harvesting season, it's not unusual to have a little rust. Both rusts and smuts are plant pathogens, so they will only grow on living plants. So they're generally not found in an indoor situation. And then Aspergillus and Penicillium. This is on the right-hand side an aspergillus, and it's named for the little club-like structure here that is an aspergillum. And if you watched them install the last pope, you remember the little guy coming down the aisle with the bucket and the aspergillum slinging water to each side. And so the aspergillum name existed before this was named aspergillus. But basically, off of the center here, you get fingers, and then you get tiny little spores produced, each of these little round things. And looking at them under a microscope, you really can't tell the difference between an aspergillus spore and a penicillium spore. They look the same. Although penicillium, which is the Roman word for paintbrush, a penicillus, and you see this is kind of a paintbrush structure here, kind of a fingers growing off of stalk. And then at the end, you're producing tiny little spores. Again, these little spores look almost exactly like the aspergillus spores. And so they're lumped together as one group called Aspergillus penicillium. Now, if you want to differentiate these, you've got to grow them on a petri dish and take a sample off the petri dish and look to see if you have this structure, the aspergillus structure, or the penicillium structure. Okay, and so those are your major airborne pollen and spores in Kansas City. You're going to start to see quite a few ragweed in the coming weeks, and ragweed season tends to be a real biggie for the allergy community. Now, those are outdoor spores, and of course the same things you can find outdoors you can find indoors, but when you start finding more of them indoors than you find outdoors, it means you're likely to have some sort of fungal proliferation inside the house, and that can be really worrying. There's a lot of concern regarding the adverse effects of indoor fungi, but it's really difficult since there's so many different methods used to collect indoor fungi. It's difficult to compare studies, and there's a big community out there that doesn't believe that indoor fungi really causes any problems at all. So when you go out to sample a house, when you see one of these reports from an air collection, the report should have been made to prove or disprove a hypothesis. A lot of times the hypothesis could be as simple as, are there spores, is there fungal proliferation in the house? Are indoor counts higher than outdoor counts? And then your approach is basically that if you've got indoor proliferation, that means it's growing on something, and whatever fungi grows on it eats. And so it's damaging your building. And when we were doing home inspections, if it was on a commercial building or something like that, or, commercial rental property, I could a lot of times go to the owner of the property and say, listen, this fungus is eating your building, and in a couple of years, it's not going to be inhabitable, and you better do something about it. And a lot of times they would go do something about it. And our patient, who was renting in the building, living with his parents or her parents, would get a lot better. They definitely render the building unpleasant to live in, and they can cause adverse health effects. And we never inspected a building that I can remember where the indoor spore counts were 30,000 to 50,000 spores per cubic meter of air, where the individuals were not having problems. Even if they weren't allergic, that's just a lot of particles to breathe in constantly. And so I'm pretty well convinced that fungi can cause adverse health effects in just about everybody if they're high enough. So we would sample for spores, we would measure fungal allergens in the dust, we would look for microbially generated volatile organic compounds. That's that smell, that fungus smell that you get. We would look for ergosterols in the environment. Ergosterols are related pretty well exclusively with fungi. We would look for glucans, and sometimes we would look for mycotoxins. Although, mycotoxin levels and mycotoxins in houses, that's a really controversial area, and I think you've really got to have a lot of mycotoxin there before you start to get medical effects. Because one of the major mycotoxins is called vomitoxin, and if you're exposed to that, you're definitely going to know it. So mold, mold in the house, that's kind of a lay term. Fungal proliferation in the house sounds a lot more scientific. The controversies are whether exposure to indoor fungi causes health effects, what's the best way to measure exposure, what should be done if there is exposure. The remediation companies are definitely convinced you should get rid of all the fungi in your air, and they will come in and do all kinds of expensive things to help you do that. Sometimes, and some of them are very reputable, sometimes some of them are not so reputable, and it just depends on which company you get. EPA has some good publications on this, and they take a very pragmatic view. They really don't deal with the controversy, but they do say that you really shouldn't be living in moldy environments. And if you are living in moldy environments, you need to clean it up. And so they recommend remediation of all fungus contaminated buildings. Now, as far as sampling goes, you can do viable or non-viable sampling. For the outdoor environment, to produce a pollen or spore count, we always do non-viable sampling. Basically, they're collected on a slide, they're stained, they're counted by direct microscopy. Those have limitations. You can only tell what genus it is. You really can't tell Aspergillus or Penicillium apart. You only get a total count. It samples a lot of air, so you have and it has a fairly low detection limit and a rapid turnaround. It's generally cost effective, and if it's not cost effective, people are really running up the cost on them. Culture methods, however, produce whereas direct microscopy produces a total spore per meter cube, culture methods produce a colony forming unit per meter cube. It can determine fungi by species. It's generally done on a short sampling time. So you can have your concentration calculations are not exact, or not as exact. Different species have different growth rates. If you've got a lot of Aspergillus penicillium in the air, along with some other, some Alternaria or Cladosporum, the Aspergillus penicillium are fast growers, and they're going to take over. And so that's mostly what you're going to count. Spores vary in their viability. They actually have a pretty low rate. And so you could have 10,000 spores in the air, but only maybe 100 of those would be viable and would grow on the media that you're trying to grow them on. And, it takes a few days to grow these things. So it's a lot longer process, and the viability is media dependent. Some spores just don't like to grow on the standard media. These are some of the things we use to do indoor counts. Pretty much everybody now uses an aerosol. It's just a little plastic cell that you hook to a pump that's calibrated. You pull through so much volume of air. You take the little coated slide in the aerosol, and it's not coated with silicone grease. It's coated more with a gelatinous material that catches spores real well. And you count this, and you do one of these, say 2 or 3 of these in a house, and then one outdoors, and you compare the indoor to the outdoor, and you get a pretty good idea of what's in the air in the house. This is an Anderson sampler. You take this is like 6 layers. You take a petri dish and you put it in each layer, the holes differ, and so tiny little spores will come all the way through the bottom where the big spores will get stuck here at the top, and you get a really good indication of what's growing in the house, but it's very labor intensive. It's hard to put together. It's hard to take apart. It takes days to grow. Some of the ones at the top may take a week or so to grow, and it's very labor intensive, but does a very good job. And there are abbreviated types of this too. Basically, air is pulled through the top here into this chamber, and spores are separated by size. And then this is the Allergenco sampler that we used a lot, but these basically are not really used much anymore. I don't think you can buy one new. You can certainly buy them used. Basically, you want to provide the best representation of the environmental conditions on the day of sampling. So you have to remember these are snapshot things. And there are lots of other collectors. This one on the right here is used in the space station to the International Space Station to do a spore. Every now and then this is used to collect on a petri dish as the turntable here spins over time. This is a viable one-time use only sampler that basically is a petri dish with a slot with a bunch of holes over it. So there are lots and lots of different samplers out there. There are personal collectors that you can put on people that go into different areas and try to collect what they're being exposed to, and it's used a lot for environmental allergy. And you can do visual counts or culture methods, and also in some of these use immunoassay methods to determine what spores what allergen levels you have. And this is one that we did a couple of years ago that compares the count of ragweed in the air particles versus ragweed allergen in the air. And we had a collector that would collect air samples in a liquid form, and we did an immunoassay on ragweed for all these different points. And so you can see that air collections for pollen and spores are good indicators of what's in the air, but they are not exact indicators. So sometimes you can have high allergen levels and only moderate spore levels, and sometimes you can have really high spore levels and not necessarily that high an allergen level. But always, if the spore is there, the allergen was there also. And that's the end of my talk. Just emphasize that these things are estimates, and so if you're ever asked to testify in court on these things, you want to make sure that you indicate that these are not exact counts, that they are only statistical estimates of spore levels. Okay. So thank you, everyone.